Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 1 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2071. Maximum number of tasks you can assign. Okay, so this problem is marked hard by LeetCode, but by the end of this video you guys will find this problem very easy. Okay, so let's read the problem statement first. You have n tasks and m workers. Okay, so here this is nothing but n tasks and m workers. Okay, done. Now after that, each task has a strength requirement stored in a zero indexed integer array tasks, where the ith task requiring tasks of I strength to complete. Okay, so here strength requirement. Alright, so here let me write strength requirement. Okay, done. Alright. The strength of each worker is stored in a zero indexed integer array workers with the jth worker having workers of j strength. Alright. So here this is nothing but strength. Okay. So let's write strength here. Alright. Each worker can only be assigned to a single task and must have a strength greater than or equal to the task's strength requirement. Okay, so strength, it should be greater than or equal to the strength requirement. All right, each worker can only be assigned to a single task. Okay, each worker can only be assigned to a single task and must have a strength greater than or equal to the task's strength requirement. Okay, clear? So that simply means workers of j value, it should be greater than equal to tasks of I. Okay, so that's why I was writing all this stuff: strength requirement, strength, and m, and task. Okay, now it's clear, right, what we need to do, right? Okay, additionally, you have pills, magical pills that will increase a worker's strength by a strength. Okay, so we also need such type of pills, okay, to increase our strength, right, while solving such type of problems, right? Okay, so you have pills, magical pills that will increase a worker's strength by strength. You can decide which workers receive the magical pills. However, you may only give each worker at most one magical pill. Okay, so we can decide that which workers receive the magical pills, right? And you may only give each worker at most one magical pill. Okay, at most one only, right? And how many pills are there and what is the strength that we are going to gain? Okay, so this is given here. Given the zero indexed integer array tasks and workers and the integers pills and strength, we have to return the maximum number of tasks that can be completed. Okay, so now see this example number 1. So these are tasks, that simply means strength requirements, and these are the workers and pills and strength. Okay, so here first let's do one thing here. Let's just sort the tasks, okay, based on the requirement, strength requirement. Okay, so my tasks are going to be like this: 1, then 2, and then 3. Okay, I have just sorted them, okay, based on the strength requirement. All right, so this is nothing but my strength requirement. Okay, so these are nothing but the tasks. Okay, now same way, store these workers in the increasing order only, right? So 0, 3 based on their strength. Okay, so this worker is having this strength. Okay, strength, right? So increasing order only. Okay, and these are the tasks. Okay, so now here you see first, let's try to complete this task. Okay, let's try to complete this task. Okay, so if I want to complete this task, okay, so requirement is 1. Okay, requirement is 1, strength requirement is 1, right? So can this worker can finish this task? No, right? So here this workers of j value, is smaller than this tasks of I value. Okay, but what we need workers of j value should be greater than equal to the tasks of I. So this worker can't finish this, right? This worker can't finish this task. Okay, but if I give the magical pill to this particular worker, okay, I have only one pill, and if I give that pill to this worker, okay, so now this worker strength is going to become 0 plus 1. Okay, so strength total, okay, total strength is going to become 1. Okay, so now this workers of j value is equal to this task of value. Okay, so if it is equal to also, then this worker can finish this task. Okay, so then we are good. Okay, right. Now same way, see this worker having strength 3 and strength requirement just 2, so he can also finish. Okay, we can also finish this task. Okay, task 2. This worker is having strength 3 and the strength requirement is just 3 for this particular task. Okay, right, so we can also finish this task, right? So now we can finish all the 3 tasks, right? So output is 3. So we can assign the magical pill and tasks as follow. So give the magical pill to worker 0, assign worker 0 to task 2. Okay, so worker 0 here 0 1 2 0 1 2. Okay, so worker 0 to task 2. Okay, so here we just give the one pill, right? So here I'm adding plus 1, 0 plus 1, and this value is equal to 1, right? So we can finish this task 1. Okay, same way, if you assign the worker 1 to task 1, then also 3 values greater than equal to 2, you can finish the task. Okay, so this is actually what we need to do here, right? I hope that you guys are clear how we are getting this output. Okay, right? Okay, so this is done, but what we need to return, we need to return the maximum number of tasks that can be completed. Okay, so this is our ultimate goal. Okay, maximum number of tasks that can be completed. Okay, so we will come to this point. Okay, first let's understand the example number 2. Okay, so these are the workers fields. Okay, so first tasks, so first task, just sort them in increasing order. Okay, this is nothing but the strength requirement of a particular task, strength requirement. Okay, so let's say this is my task 1, this is my task 2. Okay, and this is 0 index, this is 1 index. Okay, now same way here workers 0 0 0. Okay, sort them in increasing order, already sorted, so these are nothing but strength. Okay, so now here first, here see 0 na, we can't complete this task, right? Requirement is 4, but we have just this strength. Okay, so I give this pill to here. Okay, only one pill we have. Okay, and now the strength is going to increment by 5. Okay, so 0 plus 5 5. Okay, so now I can finish this task. Okay, I can finish this task, done. Next time we don't have any pills, right? And we can't finish this task. Okay, so only one task can be completed. Okay, we can assign the magical pill and task as follow. Give the magical pill to worker 0, assign worker 0 to task 0 or 1. Okay, it's your choice, but here we are sorting, so here we assign to this. Okay, so 0 plus 4 is 0 plus 5 is greater than equal to 5, or if in your case, okay, the example that here I took, I sorted now, so here you can say 4. Okay, so only one task can you complete. Okay, at most. So this is output is 1, that's it. Okay, now say, see this example number 3. These are the tasks. Okay, sort them in increasing order. This is nothing but strength requirement. Okay, strength requirement, and these are the workers, so these are nothing but strengths. Okay, so pills, we have total 3 pills. Okay, and strength is equal to 10. All right, so here first this can't finish this, right? Strength is 0, but requirement is 10. So if I give the magical pill to this, okay, so pill count will be decremented by 1, and here we have this 10. Okay, then we can enable. Okay, here same way, here if I give the pill, so here it is going to become 20, pill will be decremented to 1, and here this can be completed. Okay, now here if I reach here, I have one more pill left. Okay, if I give the pill here, so strength is going to become 20, but we are not able to complete this task. Okay, because here 30. Okay, same way, now there are here also, here the pill doesn't work, right? If we give pill here also, it will not really work. Okay, and but since we have already sorted them in increasing order now, so you can, maybe you can try to check from behind. Okay, so we will discuss about this point, how you are going to check. Okay, but here only 2 are valid cases. Okay, so output is 2, that's it. Okay, done. Now these are the constants. Okay, tasks dot length, workers dot length. Okay, and value. Okay, and pills values, okay, and all this stuff. Okay, so these are the constants. Okay, so here this is the example using which I'm going to explain actually what is going to happen, because it is going to cover a lot of edge cases. Okay, but before that, before proceeding further, here this is looking simple, right? Like if I assign this, but how that we need to check na, how we can assign the maximum number of tasks that can be built. Okay, so that is why this problem is hard. Okay, it's not like easily that just check this and assign this here. Okay, that's not it. Okay, so let's check in detail how we need to do. Okay, so now let's suppose if we already know. Okay, so before starting this example, let's write something here. Okay, so if we already know that definitely we can complete k tasks. Okay, so here if we already know that we can definitely complete these k tasks from this tasks list. Okay, so tasks list, and let's say I have already sorted them in increasing order. So this is task 1. Okay, task 2 is bigger than task 1. Okay, task 3 is there, then task 4 is there. Okay, I have already sorted them in increasing order. Okay, in increasing order. So task 1, then task 2 is bigger than task 1, task 3 is bigger than task 2, task 4 is bigger than task 3. Okay, now here these are the workers, and I have already sorted the workers also in increasing order. So w1, w2 is greater than w1. Okay, and w3, okay, w4, and let's say w5 here. Okay, I have already sorted them in increasing order, and you already know that what is this? This is nothing but the strength requirement. Okay, and this is nothing but the strength. Okay, and in total how many tasks we have here? We have total 4 tasks. Okay, 1 2 3 4 tasks. Okay, so out of these 4 tasks, if I am saying that we know that we can complete the k tasks. Okay, so let's say these are my k tasks. Okay, okay, so let's suppose these are the tasks that I can complete. Okay, so these are already sorted in increasing order. Okay, so okay, so here that simply means we can select k tasks with the minimum value in the tasks. Okay, with the minimum value in tasks. Why I'm saying with the minimum value in tasks? With the minimum value in tasks. Okay, so if we are able to complete T3, then we should be able to complete T2 and T1. Okay, but here I'm not saying that until here I'm able to complete k tasks. I'm saying that until here only I'm able to complete the k tasks. Okay, so if I'm able to complete k tasks, okay, let's suppose k value is 2. Let's suppose k value is 2. Okay, so if I'm saying that I'm able to complete 2 tasks, and I already know that t1 value is less than t2, t3 value is greater than t2, and t4 value is greater than 2. Okay, so if I'm saying two tasks, so that 2 tasks should be these 2 na, minimum ones, right. I can't take these 2. Okay, so if I am able to complete these 2, then I should be able to complete these 2 as well. Okay, if I am able to complete this task, then I should be able to complete these 2 as well. Okay, so here if we already know that definitely can complete k tasks among these tasks, okay, then we can select k tasks with the minimum values in the tasks. Okay, and here we can select the k workers with the maximum value in the workers. Okay, why maximum? Why I'm taking the maximum here? Okay, so this is also given, right? This worker 1 is having smaller strength than worker 2, worker 3, worker 4, or worker 5. Okay, so if we are only able to complete these 2 tasks, then definitely these 2 tasks should be completed by the workers having the stronger strength, right? We are not able to pass this strength requirement. Okay, why we are not able to pass this strength requirement? Because the my worker with the maximum strength is not able to pass it. Okay, my worker with the maximum strength is able to pass this test. Okay, because here my worker 5 strength was greater than, okay, was, you can say how we are writing here, workers strength is greater than, was greater than equal to my task 2. Okay, so this was valid, but this was not valid. Okay, this was not valid for T3. That is why here my worker 5 is able to complete the task 2. Okay, so this, right, and then worker 4, let's say, is going to complete this task 1. Okay, that's it. Okay, this is having the more strength requirement. Okay, even my stronger worker is not able to complete this. Okay, so we are not able to complete this task. Okay, this one we can complete worker 5. Okay, and here let's say this worker 4 is able to complete this too. Okay, done. Okay, done. Right, so here what I'm saying, if we already know that definitely we can complete k tasks, okay, then we can select the k task. Okay, so here we are sure that we are able to complete 2 tasks. Okay, here my k value is nothing but it is, we are assuming, right, we are able to complete these 2 tasks. Okay, so if I want to pick these 2 from the task, then they should be the minimum ones from here, and the worker should be the maximum one from here. That's the simple line. Okay, if we are sure that k can be completed, pick the minimum from tasks and maximum from workers. Okay, this is done. All right, so now here we are sure, right, k is equal to 2. Okay, now this is your hint 1. Okay, hint 1. Okay, now hint 2. Let's come to the hint 2. All right, so now if we can complete k tasks and satisfy hint 1. Okay, if we can complete k tasks and satisfies the hint 1, okay, then we can definitely complete k minus 1 tasks as well. Okay, k minus 1 tasks. Okay, and we can choose k minus tasks with the minimum values, and k minus workers, k minus 1 workers with the maximum value, right? Okay, which also satisfies the hint 1. All right, so this is very clear, right? K is equal to 2. We are assuming that we are able to complete k task. We are assuming that we are able to complete 2 tasks. Then these 2 tasks should be minimum. Okay, and worker should be 2. Okay, so if for k, okay, if I k minus 1, okay, for 1, so then for 1 this should be the case, and from here this should be the case. That's it. Okay, this is done. All right, so these 2 are the hints, just keep them in mind. Okay, so now after that here let's consider the task with the maximum value. Okay, so here let's consider the task with the maximum value, tm, task with the maximum value. Okay, so now here if you see, if the workers value is greater than or equal to the task value, okay, workers value is greater than or equal to the task value, then we definitely do not need to use the pill. Okay, if the worker value is greater than the equal to the task value, then we are not going to use the magical pill, right? We are not going to use it. Okay, and we must definitely let the worker with the maximum value complete the task. Okay, worker with the max value complete this particular task. Okay, task with the maximum value. All right, in this case pill is not required. Okay, but okay, so now this is done. Okay, right, so here here how can, okay, so yeah, so here see, this task is having, let's say, max value. Okay, which this worker 5 is able to complete. Okay, so definitely I'm going to assign this to here only, right? Done. Okay, now here one more case. Okay, I am only considering the cases with the task with the maximum value. Okay, so this is the first case for the task with the maximum value, right? Task with the maximum value, first case is if the workers value is greater than the task value, then I'm not going to use appeal. Okay, and definitely I am going to assign that particular work to that particular worker only. Okay, this is first case. Now let's move to the case 2. Okay, so if all the workers value, okay, if all the workers value are less than the value of the task, okay, the value of the task, right, then we must use the pill to have one worker complete the task. Okay, in that case we have to use the pill, okay, to complete the task. Okay, and in that case we must ensure that the worker with the minimum value completes the task. Okay, worker with the minimum value, okay, worker with the minimum value completes the task. Okay, so here in case 1, what we were saying, if the workers value is greater than or equal to the task value, then we definitely do not need to use the pill, and we must definitely let the worker with the max value complete the task. Okay, and here we are saying if we are using the pill, then use the worker with the minimum value. Okay, and why I'm saying so, let's understand that. Okay, so let's say you have this task requirement. Okay, tasks, here I'm writing tasks. Okay, and task requirement is 11. Okay, and now you have the workers strength. Okay, so here workers, and you have these two workers. Okay, one is having 8. Okay, and one is having power 10. Okay, now you have one pill, you have just one pill. Okay, and that particular pill strength is 3. Okay, right. So now if you give that particular pill to this one, okay, then yours the total strength is going to become 10 plus 3 13. Okay, and here if you give to this 11. Okay, so now here I am saying that use this worker, then worker with the min value. Okay, so here this is a worker with min value. Okay, so here if I give the pill to this, then this can finish the task. Okay, if I give the pill this to this, then this can also finish the task. But in that case, choose the minimum one. Okay, choose the minimum one. Why I'm saying so? So let's say if I choose this. Okay, if I choose this. Okay, then we are good. But here, okay, then we are good if we choose this. Okay, and if we don't choose this. Okay, if we don't choose the pill here, okay, use this. Okay, now here next time, let's suppose there is one task here having value 9. Okay, having value 9, let's say. So now here if you use this, okay, if you use your only pill, you have just one pill. Okay, if you use your just one pill here, then with this you are able to complete this, right? And with this you will be able to complete this without using any pill for this task. Okay, but here if you don't do this, okay, if you use your pill here, okay, then you will be able to complete this. But with this you are not going to able to complete this task. Okay, so if I'm choosing the, if I'm using the pill here, then I am able to complete 2 tasks, right? But if I am not using the pill, choosing the pill here, okay, but instead of that choosing that here, then I'm only able to finish the 1 task. Okay, so this is bad. So that's the 2 cases. Okay, right. So here again let me iterate. Okay, so let's, if we consider the task with the maximum value, okay, at which point there will be 2 situations. If the worker value is greater than or equal to the task value, then we definitely do not need to use the pill. Okay, so save that pill. Okay, and we must definitely let the worker with the maximum value complete the task. Okay, since we have already sorted them tasks and the workers values and greaters now, so from here is the max value, so we should be able to complete the task with the max value. That's it. Okay, then before that check with before that. Okay, no issues. Okay, right. And but if in case worker value is less than a task value, and we are going to consume the pill, okay, and using that pill we are able to finish the task, then in that case choose those worker having the minimum value. Okay, so if all the workers values are less than the values of the task, then we must use the pill to have one worker complete the task, and we must ensure that the worker with the minimum value completes it. Okay, so these 2 points, just keep this in mind. Okay, here these 2, and here also we discussed few things, right? Yeah, these 2 hints. Okay, hint 1 and hint 2, and these 2 points. Okay, so now let's move to the this particular example. Okay, with this example your many doubts will be cleared. Okay, so first thing, just sort your strength requirements. That simply means strength requirements in increasing order. That simply means tasks and the strength. Okay, strength is nothing but the workers. Okay, so now here how many tasks we have? We have 4 tasks. Okay, 1 2 and 3 and 4 tasks. Okay, and now here if I just give the indexing 0 1 2 3, okay, and here 0 1 2 3 4. Okay, indexing. Okay, and here task is representing n value, right? N, and here this is m. Okay, so here n is equal to 4 in this case, right? Clear. And here m is equal to, okay, length, I'm talking about length, m is equal to 5. 1 2 3 4 5. Yes, okay, done. N is equal to 4, m is equal to 5. Okay, and these are the indexing, and these are tasks 1 2 3 4. Okay, so now here first thing, what you need to do, okay, how you are going to solve this problem. Okay, so we are going to use the binary search. Okay, so here what are the approaches that we are going to use? We are going to use binary search and the greedy selection of workers. Okay, so I have already given you two hints first. Okay, hints first, in these two first. Okay, k value. Okay, if we assuming this k value, that we should be able to complete these two. Okay, so here what I'm going to do, in this example, okay, I'm going to take the left value as 1, and I'm going to take the right value as the math dot min. Okay, minimum among the length of my tasks, that is nothing but n, and the m. Okay, so m is nothing but the workers length. So my r is going to be 4 and 5, which is minimum. 4 is minimum. Okay, r is good 4. Okay, now here I'm going to calculate the mid. Okay, how we implement the binary search. Okay, same. So l plus r divided by 2. Okay, 1 plus 4 divided by 2, so I will get 2. Okay, so I'm going to run one while loop. Okay, and inside this while loop I will execute that while loop while my left is less than equal to r. Okay, while my left value is less than equal to r. Okay, I will execute this while loop. Okay, and inside that while loop I will calculate the mid first. Okay, so now I am going to check if I am able to complete the two tasks. Okay, I'm going to check. I'm going to use one if condition, and I'm going to make a check on it. Okay, if I'm able to finish the two tasks. Okay, so here see, 12 is the strength, and we should be able to complete this. Okay, and you already know that why I'm checking this task and from this work. Okay, here min, here max. Okay, I've already explained this. Okay, now with 11 I can finish this 5, right? Okay, so yes, so this is going to be valid. Okay, we are able to complete the two tasks. Okay, and we already see what are those tasks. Okay, now here if we are able to see if we are able to pass the two tasks, then we have to optimize our choice. Okay, then we have to check whether we can complete three tasks maybe. Okay, two is possible, maybe three is also possible. Okay, we have to, then what we need to do, we have to increment my here we have to increment my left value as mid plus 1. Okay, mid plus 1. Okay, so my left is going to become 3 here. All right, sorry, left 1 plus 2 3 here. Yes, right. Okay, and in the answer, okay, right now current answer I will store that with the two answer is possible. Okay, so I'm going to store this. So answer, in the answer value I'm going to store mid. Okay, mid value with the two answer is possible. And now I am thinking about maybe with 3 also possible. Okay, so inside this if condition I'm going to check this. Okay, I'm going to make l is equal to mid plus 1. Okay, so if I do l is equal to mid plus 1, okay, so for the next iteration my l is going to be 3. L is going to be 3, right? And my r is also 3. R is 4. Okay, r is 4 here. Okay, there is no impact on 4. So 3 plus 4 divided by 2, 7 divided by 2, I'm going to get 3. Okay, so next time my mid is 3. So with 3 I'm going to check. So with 3 also, see here, 11 with 12 I'm able to complete. Okay, 12 is strength. Okay, with 11 I'm able to complete 5, and with 8 I will be able to complete this 3. Okay, I will be able to complete with 3. Okay, so again I will have to check with 4. Okay, then I have to check with 4. Right, so again this is valid, so answer is going to be mid. Okay, so 3, answer is going to be 3 this time. And now left is going to be mid plus 1, so 3 plus 1 4. Okay, so left is going to become 4. So here I'm going to check with the 4 is also less than equal to right. So here 4 plus 4 divided by 2, we are going to get 8 divided by 2, 4 as the mid. Okay, so with mid as 4 I'm going to check again mid as 4 answer is possible or not. So here if you see with the mid is good 4. Okay, so now here see one more thing, with mid is equal to 4 you are going to check. Okay, so now with mid 4 that, okay, so with mid 4 you see that you have one worker 6. Okay, you are going to use this 6 one worker. Okay, with 8 you have one worker, with 11 you have one worker. Okay, and with 12 you have one worker. Okay, so this is nothing but, I can say this is nothing but my tree map. Okay, in tree map we have values in the sorted order. Okay, in increasing order of keys. Okay, so 6 8 11 12. Okay, so here Okay, so now how many tasks we have to check? We have to check the tasks 4. Okay, so 4 tasks are possible or not. So 4 I'm going to start from the beginning. Okay, here these 4 I have to check. So there is one formula na, there is also one formula from where I have to start. Okay, so first I'm going to check the tree map with the last key. Okay, so here I'm going to check this key. Okay, so there is one function. Okay, how we are going to get this key? So you can say this is nothing but my last key in the tree map. Okay, so from this tree map, what is my last key? So last key is 12. Okay, so I'm going to take this and I'm going to compare this strength. Okay, this strength and strength requirement, how I'm going to get. So what is the total length of this my tasks array? 4 minus 4 minus, here what you need to do, I is equal to, your I is going to start from my 4 minus mid values. uh, what is your mid value here? Mid value is 4. Okay, so here what you need to do, here just do I start from I start from 4 minus 1. Okay, so 4 minus 1 is going to be 3. Okay, so you have to check from the opposite. Okay, 4 minus 1 is 3, so 4 is your mid, minus 1. Okay, this is your I value. Okay, starting value, I is equal to min minus 1. So this is 3, so this is 3 index. Okay, so you are going to compare this 12 with this 13 first. Okay, so that's how we are checking now, this 12 with this 13. Okay, so max worker with the max task. Okay, here which but it's possible in this range. Okay, I is equal to min minus 1. Okay, so like in case of 2. Okay, so in case of 2, what you are checking, you were checking this 12 with the 5 and this 11 with 3. Okay, so how you are checking with this 12 with 5? So I is equal to starting from mid minus 1. So in that case, when your mid was 2, so 2 minus 1, so you are going to run one loop here. Okay, so first your I will be here, then I will be here. Okay, in backward direction it will move. Okay, so that's what I want to say. Okay, so this is done. All right, so let me just, okay, clear it. Okay, so now here your I is here. Okay, so now you are going to check strength is 12. Can you complete this task 30? Tell me. No, right? Strength is just 12, requirement is 13. You are not able to complete this task. So now what you are going to do, you are going to use the pill in this case. Okay, so now here how you are going to do that? Okay, so that's what you need to check. Okay, so you, if now your p value, right now p value here in this case, there are total 2 pills that you can use. Okay, so now what you are going to do, check the pill. Okay, so you are going to use the pill. Okay, so now if you are going to use the pill, okay, then definitely what will happen? So now I'm not going to increase the power here, but I'm going to decrement it. Okay, I'm going to decrement this. Okay, so here my mid is showing, my mid is saying that let's consider that you are able to complete the 4 tasks. Okay, so I have to consider this as well. So from here 13, if I reduce the strength, okay, 13 minus strength, okay, strength is 3, so 13 minus 3, 10. Okay, this is what is coming up. Okay, 10. All right, so now here 13. Okay, so what I'm going to do, I'm doing here, the like I have workers na here, like 8, 11, 12, there are some workers. Okay, so instead of adding the strength here, okay, in the workers and then checking, instead of this, what is the total requirement of the stat strength of that particular task? 13. Okay, and I know that I want to complete this task. Okay, that's what I'm considering. Okay, mid value is nothing but it's showing that you will be able to complete this mid task. Okay, just find out is it possible or not. So if it is possible, then what I'm doing here, for this 13, I'm decrementing stat. Okay, instead of plus 3 here, I'm subtracting minus 3, so I'm getting 10. Okay, right, so this is how I'm getting 10 here. Okay, so now with this 10, okay, so 10 is the strength requirement now. So if 10 is the strength requirement, then I already told you that we need the worker with the minimum value. Okay, so I will be able to use this here. Okay, 11 plus, I will be able to use 11 here. Okay, to complete the task for this one. Okay, why? So I have already explained it here. Okay, this here. Okay, so see, in this 12, if you add 3, 12 plus 3, okay, you are going to get 15. Okay, and here in this 11 also, if you do 3 14. Okay, so use this one now with this 11. Okay, with this it's not still not possible, so we are not going to use p layer. These are the two options, so use this. Okay, so with 11 13 this will be done. Okay, this is done. All right, so now just reduce the frequency of this to 0, and since we this becomes 0, so remove it. Okay, so now again, if you see in your tree map, this is still there, 12 is still there. Okay, now I'm going to check this 12 with this value of I, so I value is moving backward. Okay, so this, so 12 and 11 possible. Okay, done, possible. So here this is going to become 0 and we are going to delete it. Then I this, so here 8 is the last key in the tree map. Okay, last key. So with 8 5 is possible, with 6 3 is possible. That's it. Okay, so we will be able to complete 4. Okay, so now in the answer I'm going to store 4, and left is going to be mid plus 1, so left is 5. Okay, so now here 5 is less than equal to right, 4 or false. Okay, we are going to exit, and this answer is going to be my final answer, 4. Okay, so this is what we need to do, right? Okay, so these are the only few points, right, that I want to cover here, and this problem is very easy right now, if you guys see, so easy. Okay, and here, yeah, this is the last key. Okay, this is always going to give me the key in the last. Okay, and in the tree map we sort the keys in increasing order. Okay, this is the last key, and here like this 10, how we are going to search the value, like 11 we are going to use here. So what I'm going to do here, I'm going to use one function. Okay, so there is one function, right, seal key, something like that. Okay, so we are going to use that. Okay, so here this spelling, if I write CIEIL, sealing key. Okay, this is one function. Okay, in this sealing key. Okay, so what is your map name? Okay, so from tree map, let's say tm dot sealing key, and here you are going to pass 10. Okay, so what it is going to do, okay, tm dot sealing key, and in this if you pass 10, it is going to find the value in the tree map. Okay, in your map, which is equal to 10 or greater than 10. Okay, first value. Okay, so you are searching for 10, and in your map you have values like 11 12 13, so it is going to search, give the first one. Okay, here 8 9, it is not going to give 8 9, it is going to give 11 first. Okay, sealing key means the first value which is greater than or equal to this value that we are passing inside this. Okay, so we are just going to decrement the frequency of that here. Okay, and that's it. Okay, so easy, right? And if you want to see the dry run of this particular example, so here I have pasted the code, this dry run outputs. Okay, so this is the same example, right? 3 5 11 13 4 6 8 11 2, periods is 2, strength is 3, output is 4. Okay, so first checking for mid 2, so then 11 frequency is 1, 12 is 1. Okay, assigning task 5 to worker 12 can complete the task 5 without appeal, worker 11 can complete the task 3 without appeal. Okay, so until, okay, so we can assign two tasks, so operating answer 2. Okay, so this is part 1. Okay, done. Okay, done. Now for part 2, let's see. So now checking for mid is equal to 3. Okay, checking for mid is equal to 3. Okay, so workers available, so workers available 8 1 11 1 and 12 1. Okay, so these three are available. Assigning task 11 to worker. Okay, so here assigning task 11 to you can use here na, 12 can use 11. Okay, 11 can solve this, 5 8 can solve this. Okay, so you can do that. Okay, so assigning task 11 to worker 12 can complete task 11 without appeal. Assigning task 5 to worker 11 can complete task 5 without appeal. Assigning task 3 to worker 8 can complete the task 3 without appeal. Okay, so that's what. So here see, this is how we are writing. Okay, now checking for mid is equal to 4. Okay, so here see, here now see 6 1 8 1 11 1 12 1. Okay, these 4. Okay, we are picking the max workers with max strength. Okay, and assigning task 13 to worker 11 can complete task 13 with the appeal. Okay, so here I'm saying that this worker is going to complete this 13. Okay, with the appeal. Okay, I already told you why we are picking minimum one. Okay, and then here worker 12 is completing the task 11 without appeal. Okay, right, and then 8 can work finish 5, and this 6 can finish 3. Okay, 8 can complete task 5, 6 can complete task 3, and we can assign 4 tasks, update answer to 4. Okay, that's it, output is this. Okay, so that's it. Okay, because I want to minimize the use of pills. Okay, because pills are bad, right? Don't take pills unnecessarily, right? Pills are bad, there are no magic pills other than LeetCode, right? So now let's write the code. Okay, so I hope that you guys are clear with the explanation, and if you guys have any doubts about this, then just write in the comment. I will try to answer that. Okay, and code is also going to be very simple for this one. All right, so here what is the first thing that you have to do? Just sort the tasks array and the workers array. Okay, so here arrays dot sort tasks, then sort the workers array, arrays dot sort, and here workers. Then after that, once this is done, so n and m value we have to calculate. So n is nothing but tasks dot length, and your m is nothing but workers dot length, okay. And now here you have to take the left value started with 1, okay, because minimum task should be 1 only, okay, and max task is going to be the math.min of right. Okay, so range now we have to pick the range. Okay, so right is equal to math.min of your n and m, okay, and here this is done, and take the answer value to 0 initially. Okay, so 3 variables I'm declaring. Left is equal to 1, right is equal to math.min of n and m, and answer equal to 0. Okay, this is done. Then we have to use the binary search to maximize the number of tasks assigned. So here simple binary search. Okay, left is less than equal to right. Okay, so here mid you have to calculate. Mid is equal to left plus right, okay, divided by the 2, and then after that just check if this mid answer is possible. Okay, so here I'm just going to call one helper method, check, and in this just pass the tasks, okay, whatever the tasks we have, how many workers we have, okay, and pupils and the strength, okay, pass everything. Okay, this is going to be boolean. Okay, it is just going to return that whether an answer is possible with this mid value or not. Okay, so strength we are going to pass, right, and other than this what you need to do, you have to pass the mid as well, right, with this mid. Okay, so these three you have to pass. Okay, so now here if this is valid now, so you have to update this in answer you have to add this mid. Okay, then you have to check the wide range. Okay, so with the 2 is possible, then with 3 may be possible. So in that case you have to just increment the left value as mid plus 1. Okay, so that's simple binary search that we do. All right, but here in suppose with the 2 answer is not possible, then you have to shorten your range. So in that case you have to decrement the right to be mid minus 1. Okay, I hope that you already know how this binary search is written. Okay, so here let's suppose this, okay, left is here, right is here, okay, and this is value is coming as mid. Okay, so if your answer lies in this side, okay, so if mid is possible, then you have to check that maybe your answer lies in this range. Okay, so next time your left is going to be starting from here, left is equal to mid plus 1. Okay, that's what we did, left is mid plus 1, right, and then you are going to check this, maybe in this range your mid exists. Okay, if your mid, okay, but if your mid is not possible in this, okay, from here to here your mid is not possible, then in that case your right is going to be become mid minus 1. Okay, mid minus 1, that simply means that you have to check in this range, maybe your mid x is successful here. Okay, so simple basic binary search. Okay, so this is done, right, this is here your binary this binary search ends, and from here just simply return answer. That's it. Okay, now just write the code for this. Okay, this check method, right, so here from here and here write a boolean. Okay, private boolean, and here you have to check, and inside this check what you need to do, you have to pass all these things. Okay, task, workers, fields, strength, and mid. Okay, and here just pass the mid. All right, now here once this is done, then how many fields we have in, let's say variable int p is equal to fields. Okay, this p value is storing the fields. Okay, now you are going to use tree map. Okay, and in this tree map we are passing keys as integer type, and values are also of integer type. Okay, and let's name it as ws, okay, is equal to new tree map. Okay, so in this tree map I am adding the workers strength. Okay, so this is done. All right, now after that, once this is done, so we are going to add the top mid workers to the tree map. Okay, top mid workers to the tree map. So how we are going to do that? So I'm going to run one loop. Okay, int I is equal to the workers dot length minus mid. Okay, so here I is equal to workers dot length minus mid. Okay, so we are adding the top mid workers to the tree map. Okay, workers dot length minus mid, and here your I value, it should be less than workers dot length. Okay, and here plus plus I. Okay, and then after that, here what we need to do, we have to add ws dot put workers of I value, right? And here just check if that particular worker value is already there in my map or not. Okay, so ws dot get or default. Okay, simple normal map that we used to write, right? ws dot get or default. So just check if this key, workers of I key, okay, if it is there, then take that value, otherwise take 0 in the start and add 1 to it. Okay, so we are just storing the frequency of these two. Okay, done. So now here, once this is done, then this is for workers. Okay, so here in this part I am just storing this thing. 1 second, I think here somewhere yeah, here I mentioned, right? So this is what I'm storing: 11 1 12 1. Okay, 8 1 11 1 12 1. Okay, so this is nothing but frequency. Okay, now once this is done, okay, now after that we have to check, iterate over the tasks we want to assign. Okay, so for int I is equal to mid minus 1, and I have already explained we are why we are iterating from mid minus 1. Okay, and we are moving in the reverse direction. Okay, backwards. So here I should be greater than equal to 0, and here I decrement, right? And inside this we are going to first take the key. Okay, we are going to get the worker with the maximum value. Okay, so that simply means we are going to take the max key from here. Okay, my tree map is already sorted now. Last key is going to max 1 only. Okay, always, right? So that's why I'm saying last key. All right, so here integer key is equal to ws dot last, and here you have to write key. Okay, last key. All right, so this is going to get the worker with the maximum value. Okay, get the worker with the max value, get the worker with the max value. Okay, so this is the first thing that you have to do. And then here if you write if key is greater than equal to tasks of I. Okay, so if this is the case, then there is no need for peers if the worker can complete the task. Okay, so here what you need to do, ws dot put, okay, here that particular key, and here just reduce the frequency. Okay, we have already used this key. Okay, so ws dot get key, and from here you have to subtract 1 from it. All right, so this is done. Okay, and here if this ws dot get the value of that particular key, okay, if it becomes equal to 0, then in that case you have to remove this. Okay, ws dot remove that particular key. Okay, so ws dot remove, and here you have to pass key. Okay, this is done. All right, so now after that what you need to do, okay, so this is for if we have no use for the pill. Okay, so no need for pills if the worker can complete the task. Okay, but in the else part, okay, if no worker can complete without a pill, then we need to use the pill. Okay, so here first just one basic condition, just check if pills are available or not. Okay, so if p is equal to 0, that simply pills are not available, then simply return false from here. Done. And now in the else in here, okay, after this if condition, okay, if pills are here available with us, okay, so what you have to find out the key, okay, which key we have to use, okay. So we are going to check if any worker can complete with the pill, and we have to choose the minimum value of that particular worker, okay, minimum value of worker strength, okay. So ws worker strength, okay, this map. So here I already told you that we are going to use this ceiling key function, okay. So in this ceiling key function I am just going to reduce the that particular task, okay, tasks of I strength, okay. So tasks of I, and here I'm just going to write minus strength, okay. Why I'm using minus strength I have already explained, right? GTH, okay, this is done. All right, so we are going to check that, okay. So here if the key value, okay, if this key value comes as null, okay, so that simply means that there is no such key available, okay. So if key is equal to null, then in that case also we have to just simply return false, return false. Otherwise we are going to get some key value here, okay. We are going to get some key value which is available in their map, okay. So for that particular key we have to reduce the frequency, okay. So ws dot put here, you can just simply copy this, okay, paste it here, ws dot put key, ws dot get key -1, okay. And here also same way, if ws dot get key is going to become 0, then you have to remove that key, okay. This is done, and you have already using the pill, okay. Here in this case you are already using one pill, okay. So just reduce the frequency of p, okay. So minus minus p, okay, use up a pill, okay. So in the end here, if you didn't execute false here, didn't execute false here, then in the end your while loop, this method ends here, okay. So in here you have to turn true, okay, overall. So if you don't execute false anywhere while doing the execution, okay, so in the end just return true, okay. So now that's it. So see, only 49 lines of code, okay. So let's run the code and see if there are any code issues. We'll try to fix that. So yes, so here tasks should be there, right? Tasks, let's run it again. So see, all the test cases has been accepted. Now let's submit it, okay. So see, our solution is accepted, right? So now let's understand the time complexity of this problem, okay. So here first we are going to sort the array, and it is going to take of n log n time, okay, of n log n time complexity, okay, sorting. And same way we are also sorting this workers array, right? So here I can say that it is also taking of m log n time, okay. So here you can say of m log m time complexity for this part, okay. So now the lower bound of binary search is 1, right, and the upper bound is the smaller value between m and n, okay. So the number of times of binary search is log of minimum of mn, okay, and each search requires enumerating minimum of this mn tasks, right. And during the enumeration process deletion operations need to be performed on the ordered set of workers, okay, since we are using tree set, right, with the time complexity of a single operation being of log of minimum of mn, right. So therefore the time complexity of binary search is, okay, this complete binary search time complexity is of, okay, including this check method, okay, so is going to be, I can say, of, and inside this I can say minimum of m and n that we are going to have, okay, minimum for m and n, and then here log square, okay, because we are doing deletion also inside this, okay, and here also minimum of m and n, right. So your overall time complexity is going to be of log n log n plus of m log m plus of minimum of mn log square min of mn. So this is going to be your time complexity, okay. So binary search for this process is going to take log of min of mn, and deletion is also occurring, right, when we are deleting one key, okay. Then again tree set is arranging itself, right. So that is also going to take log of min mn, that is why square is coming up, right. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.